Okay, today's story is going to be about the cubic equation, which is the top equation. You've probably seen that one before. And the depressed cubic is the second one. That'll come up later. So, in 1492, Luca Pacioli, who is Leonardo da Vinci's teacher, publishes the Summa de Arithmetic, which is a summary of all the mathematics known in Renaissance Italy. In it is a section on cubics, and Pacioli's conclusion is that a solution to the cubic is impossible. About 2 decades later, in 1510, Scipione del Ferro, a math professor at the University of Bologna, finds a method to reliably solve depressed cubics, which is the subset of cubics without the x squared term. And he locks it away forever, as mathematicians do in this time period, because in the 1500s, your math position was at stake to anyone who wanted to challenge your position, and each would submit questions to each other, and whoever solved the most would get the position. So that basically secured or gave him job security. So he holds this secret for 2 decades and only tells a student of his, Antonio Fior, on his deathbed. Now, Antonio Fior, he boasts about his mathematical prowess, even though he's not nearly as skilled a mathematician, and he boasts about his ability to solve depressed cubics. And he quickly challenges a newly arrived mathematician to his hometown of Venice named Niccolo Tartaglia. And Tartaglia is no stranger to adversity. He grew up in poverty, self-taught himself math, and kind of clawed his way up through Italian society. So they both gave each other 30 questions, and Tartaglia gives Fior a set of 30 problems in assortment, and Fior gives Tartaglia 30 depressed cubic equations. And they have 40 days to solve the 30 equations. Fior doesn't solve a single problem, and Tartaglia solves all 30 in just 2 hours. You see, Tartaglia had heard of Fior's claims to have solved the depressed cubic through all of his boasts, and he was, with that knowledge that a solution was possible, he had set about solving the depressed cubic himself by trying to complete the square in 3 dimensions. And he summarizes his equation in an algorithm that he writes as a poem. So quickly, he became a celebrity basically overnight, now that people know that he can solve the depressed cubic. And he draws the attention of a Girolamo Cardano, a polymath based in Milan. And at first, Tartaglia refuses to reveal his algorithm, but Cardano was very persistent and sent him many letters ranging from aggressive to flattering. And eventually, with a promise to be introduced to Cardano's wealthy benefactor, Tartaglia goes to Milan and reveals his secret only after forcing Cardano to never reveal it and only write it in cipher, so that after his death, no one will be able to understand it. But Cardano has bigger plans, and he uses the algorithm to try to solve the full cubic equation, which he does by substituting x with x minus b over 3a to turn the cubic equation into a depressed cubic. So Cardano waits to publish, but he has no need to keep it secret, and he wants to publish it, but he has his promise to Tartaglia. So in 1542, he travels to Bologna and meets with the grandson of Scipione del Ferro and finds the solution in an old notebook of his, which predates Tartaglia's solution by decades. So with this knowledge, he publishes the solution without violating his oath. And 3 years later, he publishes the Ars Magna, which is an updated compendium of mathematics. And he has a chapter in it that has 13 arrangements of the cubic equation solution, because they did not like negative coefficients back then, so there was 13 arrangements of the cubic equation. And this, him publishing the solution greatly displays Tartaglia, who writes a lot of insulting letters. But the Ars Magna becomes a great achievement, and the general solution becomes called Cardano's method. And that's the story of how the cubic was solved.